Right. The modal group, yeah, we're right. The modal group is the 0 to 1 meters high. But if you have a look at the range, the other ranges are smaller than that. We've got 0 to 1.5, that's only half a meter width. 1.5 to 2, that's half a meter width. 2 to 2.5, that's a quarter of a meter width. So the actual number of sunflowers that are being represented are being grouped together in a bigger group there. And it's not really fair to compare different sized groups. Okay? So the different sized groups prevents us from using the mode at the moment. So we're not going to talk about the mode. The rest of it we've done before. So this is the modal group. And the reason it's not good, because the groups are not the same width. So unfairly wide. So this group I've chosen a bigger set of values to put in that group than I have for the others. So later in the week we'll be dealing with that for mode and be drawing something called a histogram. Okay, what techniques would I need for calculating the mean then? Let's put the mean in the middle. By the way, this table that I'm putting in, you can actually pull up the worksheet and you've got that table there. Okay, but you will have to hand draw. I've not found a suitable tool for doing the graphing. So we're doing the mean. What was the technique for finding the mean? Did this last week. How did we find the mean of a set of table data?
Everything up in it.
Frequency by what? Right, so we need mid-value. Good, mid-value. And mid-value we find by adding the two endpoints up and dividing by 2. So this is 0.5. Mid-value here is 1.25. Mid-value here, 1.75. So it's mid-value when we're calculating the mean. That one's going to be 2.125. This one's going to be 2.375 and 2.625. And so we now do the total using the calculator. I cheated, I used the calculator that does it for me and it doesn't tell me the table. So we do the multiplication through to give me 3.0. 3 times that gives me 3.75. 4 times that is going to give me 7.0. Right, yeah. That one's going to give me 6.375. 5 is going to give me 11. And I need to do this one on the calculator. So it is 5 times 375. That's 11.875. So that's mid times frequency. And we've got 4 times 2.625. It's 10.5. At the bottom we need a total. What totals do I need of? Now my frequency's been quite nice to be on this one today. Your other example ones aren't. They're not being particularly nice. They're going to be horrible numbers. So as a suitable value, round your answers to 3 significant figures is the best answer. So we're going to use 3 sig figure. I know yours are going to give you horrible numbers. I'll be talking about something else with that as well. So we've got 25 here. And I do the total of all of these. Option 1. That. The data, the total is 42.5 according to my calculator. which tells me that the mean is equal to 42.5 divided by 25, which my calculator says is 1.7 metres. So that gives us a nicer number somewhere in the middle of all our different types of frequency. Okay. We can also find the median group. We've got 25 items, so the median group, which doesn't need a table. Actually, yeah, let's do the median group. The problem with doing the median the way I'm just showing you, this is new, is that it doesn't turn around and give me a single value. It only tells me a group of numbers. Okay, but to find the median group, I've got to find the middle value. The middle value is of 25 numbers, so it's 25 plus 1 divided by 2. That's the two endpoints. So that's the big start and the end, start and end. Add them together, divide by 2, you'll find the middle. Always the case. So this gives me 13th. Where is the 13th value? So we want number 13. And we can find that in a minute. I'll talk about where else we can see this in a moment. Number 13, we've got 6, 9. This is going to be 13. So the 13th value is just in the group 1.5 to 2. Where's the middle value? So choose the two endpoints, add them together, find out which value is in the middle. Friday, we did a better method of finding out exactly a good value for it though. And that value was doing find the median by doing cumulative frequency. And to do cumulative frequency, I need to have two values again. One is the CF. How do I calculate CF? What's CF for the top line?
It's like
Top line. What does cumulative mean?
6.
Yeah, so we're adding up. So 6. Next one. Next one. 13, yeah. Now notice this 13, what we'd look at is which group are we in where we don't exceed the value. And that would actually give me my median. So there's a little note there saying, oh look, number 13 is in that position. Continuing on, we get 16, 21, 25, and again, we also check 25 over here. We've got the same value. Now, I've left another column. What's the value we plot this at? Cumulative frequency. Mean is try and find a middle point. Median, where did I say look when we're plotting?
At 50%.
That's that's when we've got the graph. At the moment I can't plot points because I don't know which point. I've got 0, 0.5, 1. Which one's the best value to put the median at? When do we know we have 6 sunflowers? Will I have gone past 6 sunflowers when I get to 0? At all? Am I certain I've gone past 6 sunflowers when I go to halfway, 0.5? Am I certain I've gone past 6 when I get to 1 metre? Which one of those 3 options am I using? And we're assuming in this range, for mean, we've done the same assumption. We're assuming that between 0 and 1, we've said that there's 1, 2, 3, 4, 5, 6, and they're evenly spaced. If they're evenly spaced, that would give me my mean value at 0.5, because the two either side, they balance out. But for median, I want to know, when have I gone past 6? So we always plot on the high bound. Because at that point, we know we've seen an accumulation of 6. So at the high bound, we've got 1.0. There's people turning their cameras off again. Can we keep them on, please? Next one. When have I gone past 9 sunflowers in total? Only when I get to 1.5. I've only gone past 13 when I get to 2.0. And 2.25, 2.50, and 2.75. Now, to get an accurate, a better estimate for the median, we can estimate it from a graph, the cumulative frequency curve. So I take my graph. I've actually set my axes carefully, so I've already set these up so that I can measure it. Horizontally is my data value. What's my data value? Yeah, the data value is the heights. We want to be able to plot points. We're not plotting groups. So my height data is going to be plotted as values, a bit like a scatter graph. So we've got 0. I've set this up so that every 4 I can write a measurement. So I've taken 12 squares to do a height in meters. Okay. Vertically is cumulative frequency. How many are there in total? And I think I set this one so that it was it 5? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 10. That's 5, 10, 15, 20, 25. Okay, so I did 2 squares is 5 when I count them up. And now we plot the points using the values in the 2 columns. So my first cumulative frequency is 1. At 1 meter, I've had 6 sunflowers. At 1.5, I've had 9. At 2.0, I've had 13. So I'm plotting these quite accurately under here. At 2.25, I've had 16. At 2.50, I've had 21. And at 2.75, I've had all 25. Okay. Now I'm just going to use a straight edge rule to try and draw these. So let's grab my pen. So I gave this a special name. What's this called when I use a straight edge? What's it called if I'm using a straight edge? Yeah, so I'm drawing the cumulative polygon. So draw the line, connect it to the points. Come on, give me that end. There we go. So I'm doing a polygon this time. I've got to swirl it round like that so it doesn't actually keep locking to the grid. Bring that back to there. So I copy those in. And my question is, how do I go about finding median and the quartile ranges? How do I find a median and a quartile range? How many sunflowers have got less than 30 metres? Still 25. So at the top, my line goes horizontal. So where do I find the median? Someone mentioned it earlier. How do I find the median? %, yeah. So think about where 50% is. Well, 25 is 100%. I'm doing it all on the same axis now. Go halfway, which is 12.5, that's 50%. And halfway between them, so that's going to be just about there. Halfway through that square is 75%. Why do I need 75%? Yeah, so I can find the quartile. So I read across at 50% and skim down. And that looks about 1.9 metres. There's my median. So median is approximately, because it's only an estimate. Why is it only an estimate? Remember, the reason for the estimates is because we've been using, well, we weren't using the midpoint. Remember, we weren't using the mid for this, Arjan. It's the upper limit. So we've taken a best guess. Both of these values we're using are best guesses. That's why it's an estimate. Quartiles, go through at the quartile point. Measure down. My upper quartile is just shy of 2.5, so upper quartile, I'm estimating about 2.4 by the looks of that, because it's slightly closer to this than the other one. And lower quartile, again, go halfway and drop it down, and that looks about 1.1. And that means that my IQR interquartile range is 1.3 metres. Okay, they're the bits that I can do to find these values. Why is the IQR better than the range? IQR is normally better than the range because the range includes extreme values. Has extremely large, and we're trying to find out typically how well grouped are things. So typically means I don't particularly want to know about extreme values. That's the purpose for them. Right, I've given you 2 sets of data to do this for yourself with. Go and have a go at them, paste them into the worksheet, please. You can put your values into the tables as you go through. Calculate the mean, the median, the upper quartile and lower quartile. I do want to see responses today, please. There's quite a few people. I'm worried you might be struggling, or you keep leaving things to later. I want to know that you understand this now. So comment at the end of the lesson or by the end of the day. But I want everybody to have their work handed in today, please. Okay.